Okay, so what we just did now is we just went through a bunch of chemical formulas and we just looked at the subscripts, and remembering this, the subscripts tell us the number of atoms. And we talked about this in the last class as well, okay? The subscript, which is the small bottom number. I say small bottom because it's at the bottom, not at the top. That's its position. Small bottom number attached to element equals to the number of atoms of that specific element in a compound or polyatomic ion. Okay, so that's the basic idea. Now you might be thinking, what's the difference between a polyatomic ion and a compound? Well, the main difference is that a polyatomic ion is actually still an ion. It's got a positive or negative charge, whereas a compound, like for example, sodium fluoride, doesn't necessarily have a charge attached to it, okay? Like an ionic compound, for example. But a polyatomic ion is still an ion, so it's still a charged ion that contains two or more elements in it, okay? So for example, just to give you a really clear comparison there, so Na plus would be the sodium ion, whereas Na2SO4 would be the sodium sulfate polyatomic ion. You've got more than one element here, okay? Whereas with sodium, that was just one element. So that's why we call that a simple ion, ION, and we call this a polyatomic ion, an ion that's made of more than one atom. That's where the word polyatomic comes from. Poly meaning more than one, and atomic meaning atom. Okay, more than one atom. Okay, that's the main difference there. Okay, let me just scribble everything out now, and let's go to the next slide. Okay, the next slide is just helping you guys to practice some chemical formulas. We're not going to do everything, just do a few examples until we get the basic idea. I think a good one would be to just choose one example and just complete one row together, and then you guys can do the rest of that, maybe as homework or maybe as practice. And then I want to do one row from the polyatomic ions as well. Okay, so we'll try to complete one row each in the next 15 minutes that we have. So just to get you guys started and just to refresh our knowledge of how to do this, okay, just remember, whenever we're doing the swapping method, okay, where we're swapping the charges, we also call it the Criss-Cross method. So if we, for example, take, let's say, magnesium, okay, we've already got the charge there given to us. You can always find that from your valency table or from your periodic table as well. So Mg2 plus or plus 2, however you want to write it. And then we've got chlorine, okay. We know chlorine is negative, but we know there's an imaginary 1 there, yeah? If the number's not there, we assume that it's a 1. We'll put the 1 there now, just for understanding. We do the Criss-Cross method. So basically now what happens is you've got magnesium taking on the charge of chlorine, which is going to be 1. And then chlorine takes on the number associated with the charge of magnesium. So it's going to be MgCl2. Okay, so that's going to be my formula. So where do I write that? I write that here. MgCl2. Okay, let's try another one. So let's have a look at, I'll do maybe one example from each box just to give you guys an idea, and then you probably can do the rest. Okay, let me just rub all of this out now. Okay, so let's not do magnesium. Let's do another one now. Let's use a different color. Okay, so let's do which one? Magnesium we've already done. Let's do potassium and hydroxide. Oh wait, we're going to do that on the next slide. So we'll skip this. I don't know why I forgot to crop all of that out. Forget about this if we've already put it on the next slide. Let's just focus on the single atoms for now. So let's look at potassium and nitrate. Okay, nitrogen. Not nitrate, sorry. Okay, so do the Criss-Cross. Okay, so basically we're saying that potassium is going to take on the charge of nitrogen here, and nitrogen is going to take on the number associated with the charge of potassium. Okay, now what that's going to look like is K, potassium takes the 3 from nitrogen, 3N. Okay, it's going to be just a normal N, no number, because remember K was just +1. We don't put the +1 there. We just imagine that it's there, but we don't actually write it down. Okay, so that will be our formula. So where was that? It's here, K3N. Okay, now this is a skill that's important, not just for chapter 3, but actually more so for chapter 4, especially because we're going to start all this kind of stuff officially on Wednesday. Okay, so we really need to understand this idea of the Criss-Cross method, swapping the charges, how to write the chemical formula when you're given 2 individual ions like that. Okay, if there are any questions or any issues or confusion, please let me know. I'm not saying this is an easy topic for everyone. Okay, so if you're having any issues, let me know, because it can be difficult at first. Okay, so let's anyway rub all of this out now and do another one. We'll leave the crisscrosses there. We need them anyway. Just rub out this part. Oh, why isn't that one going? Fine. Okay, just stay there then. Okay, let's do another one then. Let's do let's do one from sodium. Sodium and we can do sodium and oxygen. Why not? Okay, so go here, Na, and we know Na has a +1 charge, partly because it's in, or mainly because it's in group 1. Okay, and our group 1 metals form a +1 positive cation. And then we've got our O2 or O-2, O2-, however you want to write it. So basically Na will take on the charge of oxygen, and oxygen will take on the number associated with the charge of thing, which is an imaginary one there. Okay, so how we're going to write this is Na2 and then just a O. So that's our answer. So then where did I put that? It's here. Na2O. Okay, not a simple O. If you were to write this, that's wrong. If you were to write this, that's wrong. Okay, if you were to write this, that's wrong. Okay, so you need to write the proper terminology using that thing. I've been saying from the beginning that when you write chemical formulas, they are case sensitive. You have to be cautious of the letters that you use. If you use an uppercase letter where it's not required or a lowercase letter where it's not required, you will lose that mark. Okay. All right, let's try another example. I'm assuming you guys are okay with this so far because I don't see any questions in the chat box, but you need to let me know if you're not. Okay, remember that we could ask you a question about this on the test. Okay, so you do need to have a basic understanding of the formulas, not a super complex understanding. We'll go more into them in chapter 4. But for chapter 3, you do need to have a basic understanding of that Criss-Cross method. Okay, anyways, let's do another example. Which color should I use? Let's do purple. Okay, so when we look at the next one, we've got iron, so Fe2+. And let's combine it with, we've already used all 3. Let's do it with nitrogen. We haven't done much of nitrogen. Okay, so Fe2+ or +2, and then we've got nitrogen, which has a 3- charge, so 3-. Okay, so crisscross. So we go Fe, so iron takes on the number associated with the charge of nitrogen, which is 3. And nitrogen takes on the 2. Okay, so that's basically how we'd write that out. So then you would go Fe3N2. Okay. We'll just quickly do for aluminium, and then we'll do that one as well, and then we'll go to the next slide. Yeah, but hopefully you guys have a basic idea there of how to do it. Because yeah, we do need to know this skill for the test as well. Okay, that's why we're going through it again, in case you didn't understand it the first time around. Okay. Okay, let's go to another one. Okay, so let's do, for example, okay, got a question. Yeah, we don't put the charges. The numbers stay the same. I think that's what you meant to say in the question. So the numbers stay the same, but the charges we don't put. For example, here I didn't put a minus sign or a plus sign. I just dropped the charges but kept the same numbers there. Okay. So the numbers don't change because the number of atoms, they shouldn't change there. They just kind of swap over. That's about it. If we do aluminium and chlorine, for example, so aluminium is 3+, chlorine is 1-, imaginary -1 there. Okay, so we go AlCl3. Okay, and that would be the formula there. AlCl, that looks like a 1, it should be an L, 3. Okay, all we did was swap the numbers. Forget about the actual sign. It's just the numbers we're concerned with here. Okay, and then the last one is actually an example of a polyatomic ion, okay, called ammonium, which is in your valency table as well. So that's for ammonium, and ammonium is a polyatomic ion that's made up of 1 nitrogen, as we can see, and 4 hydrogen atoms. Okay, so what we're going to do now is I can just undo. That's much easier. Oh no, that undoes the answer as well. Nope, that won't do. Okay, I have more space here. I'll draw it on that side. Okay, so basically what we're doing is NH4. Now remember, NH4 is a polyatomic ion. This entire polyatomic ion has a total charge of plus, which basically means +1, but we don't imagine that the 1 is there, okay? NH4 +1, so now if we combine that with, what should we combine it with? Let's see. Should I do it with oxygen or nitrogen? Let's just do it with oxygen and see how we go there. So oxygen is 2-. Okay, so all we're doing now is we are swapping the numbers there. Okay, so basically the 2 goes to the NH4. Okay, so this is going to now be NH4. And I'll tell you why I'm putting it into the brackets in a second. Okay, and then the oxygen just remains as it is. It's just going to remain as an O there. Okay, that's the basic idea there. Or we can put the oxygen at the front as well. It doesn't really make a big difference there. Okay, so that's the basic idea, okay, for ammonium and oxygen combining there together. Okay, now why do we put it into brackets? The reason we put it into brackets is that when we're dealing with a polyatomic ion, we're actually dealing with something that's different from a singular ion. Okay, it's different from just dealing with an N nitrogen atom or ion, different from just dealing with a hydrogen ion. Okay, that whole thing, whatever we change to one item of this polyatomic ion affects the rest of it as well. That's why we put all of it safely in that bracket and then put the 2 charge outside. Okay, that's the basic idea there. So yeah, that's the basic idea. And then we put the O there. The O doesn't have a number attached to it because remember NH4 had a +1. So that remains a +1 there. Okay, so if we were to write that out, now where did I put it? Here. NH4, 2, and 0. And now guys, you can see that what started off as 1 nitrogen atom and 4 hydrogen atoms has now become N times 2, 2 nitrogen atoms and 8 hydrogen atoms because the 4 and the 2 multiply. Okay, this is really important for us when we start balancing equations. All right. Let's just, on a scale of like 1 to 10, with 10 being, oh my God, this is so hard. Can I drop chemistry? And you can't drop chemistry, obviously. But from a scale of 1 to 10, how are you guys feeling about like writing chemical formulas like this? Wow, 9.999. I like that. That's good. That's a good sign. That's a good sign. Okay. Listen, hopefully you guys are at least at a 5, 6, or 7. Okay. Just because we don't want you to lose too many marks for this. And we do really need this skill, guys, as we move into 4.1. A big part of chapter 4 is balancing equations. So that's basically the thing. Yeah. Okay, so hopefully you guys have a basic idea then. Okay, anyways, before we finish off, I'm just going to do 1 or 2 examples of the polyatomic ions, one of which we actually just did with the ammonium, but just looking at this now. Remember, polyatomic ions, you're just dealing with, just think of it as a single ion. It's just got a charge attached to it, okay? It's just like the same thing like as if you're dealing with a single ion, but you just got a charge attached to the whole polyatomic ion, okay? It's not that difficult. It just looks harder, but it's actually just the same concept. Okay, so for example, if we go K and H, like that, K and hydroxide is minus, okay, and that's a plus. So if we were to do the crisscross here, both of these are +1 and -1, so there are no numbers going to come out of nowhere there. Okay, the formula is going to look like that, KOH. Okay, we don't need brackets here because it's just 1. K1OH1 is basically KOH, okay? But we don't want you to write the 1 subscripts. Okay, and that's your correct answer. if we look at the next one, it'll be a similar process. It's going to be KNO3, again, because that's a +1 and that's a -1. So maybe let's do one with a different, let's do KSO4, okay? So when we're looking at the formula for potassium sulfate, we have to remember that potassium has a +1 charge and our sulfate has a -2 charge, okay? So basically when we're looking at that, how we're gonna write that out is we put the K there, that's got a +1. I'm gonna draw the imaginary one there. Okay, and then we've got SO4 2-. Okay, and then when we do the crisscross, what we're gonna find is that potassium, or K, takes that 2 number from sulfate, so it's going to become K2. Okay, and you can probably guess what sulfate is going to be because that's just a 1, so it's just going to be SO. It retains its 4, that's what it came with, that's what it's going to keep, it's not going to lose that, SO4, and there's no extra subscript or anything that gets in there because again that's a +1 there. Okay, so this formula will be K2SO4. Okay, maybe one more before, maybe I'll just explain this one before we go. So you guys can see here that NO3 has a 1 charge. The reason that we put the 2 outside is because NO3 actually takes on the 2 charge of iron, not ion, the element, okay? And then we put the 2 outside. So the whole of that nitrate polyatomic ion is multiplied by that 2 that's on the outside, okay? Fe stays as it is, doesn't have another number here because remember nitrate has a -1. So there could be an imaginary number 1 here next to iron, but we don't usually put it there, okay? We don't have to. Okay, so what I might get you guys to do is I might get you guys to fill this in yourself. Fill in the rest yourself. I'll upload this PowerPoint onto Schoolbox and then just fill in the rest yourself. You might have to like use a text box or something because I've pasted this in as an image. But yeah, fill in the rest yourself and see how you go. I'll post it up as a Word document so you can type in directly. That's probably easier. And make sure you are using, making proper use of your subscripts and proper use of brackets where they need to be put. Okay. All right, guys. And if you're having any issues, let me know. Those people who I messaged to email me the questions for 3.5, make sure you do that by tomorrow, 11:59 p.m. I am giving you an extra chance. Okay, I know that, you know, we've come into e-learning after a long time, but you do need to send that to me, okay? Otherwise, definitely your parents will be emailed on Wednesday, okay? I cannot delay this any longer. So make sure you are done. The rest of you for 3.6, if you can submit 3.6 by tomorrow, 11:59, that would be great. Okay, I know some of you are having issues with the diagram questions. Just email me. I'm happy to give you another example if you're having issues, but honestly, don't stress too much for the diagram questions as well. Just try your best. We're not going to ask you a really hard diagram to draw up. Okay, we know that it's kind of hard to draw the diagrams as well, but just have a basic understanding there. Okay, especially have an understanding of what the difference between a single bond, double bond, and triple bond are. Okay, by going through maybe the previous recording that we had that's on the Schoolbox or something like that. Okay, and we're just going to stop the recording here.